Welcome back to the Profitable Python. I'm your host, Ben McNeil, and on this episode, you will meet Alexy Grigorev. Alexy lives in Berlin with his wife and son. By trade, he's a software engineer with a focus on machine learning. He works at OLX Group as a lead data scientist. And some cool facts about Alexy are he's a Kaggle master. He wrote a couple of books, one of them called Mastering Java for Data Science, and the other one that he's working on right now called Machine Learning Book Camp. And that's not a typo, it's called Book Camp, which was recently released as a MEEP. So Alexy, welcome to the show.
Pleasure to be here. Hi.
Yes. Glad to have you. And one of the first things I want to talk about was, for those of you that don't know what a MEEP is, it's early access to the book. Can you talk about like the benefits that your readers get by signing up for the MEEP right now?
Mm-hmm. Yes. So MEEP is it stands for Mining Early Access Program, meaning that the book is half ready, so it's still in progress. So it's not really a complete book, just a few chapters, but it's already possible to look inside and decide whether you want to buy it or not, and then eventually also buy it. And then when the book is ready, you'll have a complete copy.
Yeah, I think there's like three chapters you can just jump into right now, right?
Yes, right now, exactly. So for the book, right now there are 3 chapters and 1 appendix. In total, there are 10 chapters, so it's like 30% ready right now.
Cool. And this is all machine learning, hands-on, like zero to hero type stuff. Get your hands super dirty with machine learning.
As hands-on as possible.
Mm-hmm. Go ahead. I didn't mean to interrupt you.
Yeah. So the idea is to learn by doing. So learn machine learning by doing projects. And every chapter is like a new project where you get a data set from somewhere, try to understand what this data set about, then build a machine learning model, and then also try to understand what's going on inside the model. So how does it make predictions? What is the output? How we can use this output? Pretty hands-on. So I try to keep the theory to minimum, but sometimes it's not really possible because at the end, machine learning is applied mathematics. So there's still a formula or two here and there, but the focus is pretty much on coding, hands-on. Get the data, process it, train a model, get the model, use it.
Awesome. And I think like the last little nugget that I wanted to just prompt you with here was all these projects are basically designed for somebody to go through and have a portfolio of machine learning,
exactly.
Like a body of work that they can go on to. It's kind of catered to like getting a job in the industry, right?
Mm-hmm. Yes. So the target reader is someone who can code already, like a software engineer or maybe a student who's already experienced in coding, but they don't know machine learning yet. So the idea is, okay, now with this knowledge that you have, like you can already code, you can just do a bunch of projects, understand how it works, get a portfolio, and already if this is something interesting for you, you can already start applying this knowledge to get a job and then continue learning on the job.
Cool. Yeah, I'm excited to see how that progresses. Okay, so when it comes or when machine learning becomes fully commoditized, what will be the areas that software engineers will need to specialize in? Because the jobs that we're applying for right now, like might not even be a thing, right?
Yeah. So that's actually indeed a trend that machine learning becomes simpler to enter for people who can code. So right now there are so many libraries where you don't need to know all this mathematics. You can just take some off-the-shelf solution and just use it. One thing is library, but other is these software service providers where you can just throw in a data set and then it will give you a model. So that's pretty cool, but I don't think it will anyhow make the jobs of data scientists or machine learning engineers go away. because I think it just helps them, because this process of training a model sometimes is tedious. So you need to try to come up with the best parameters and things like this, and it just makes a lot of you. Just give it the data, and then it gives back the model. Still, there are so many things around this, around the model. So first, you somehow need to prepare the data set. Even before preparing the data set, you need to understand the problem. What is the problem you're solving? Then you get the data. Then you prepare the data set. Then you can use either this ML as a service or use a library to train a model. And then there is a lot of work after you have the model. So you need to get the model somehow, make it available for others to consume, or integrate it into existing services, and then actually make these models useful. So that's a lot of things that are not covered by these boxes, black boxes, where you just throw in data and get a model. So there is a lot of things around. So I'm pretty sure I have job security right now as a data scientist, because these things are not going to be automated anytime soon. Maybe one little step is, but the rest unlikely.
Mm-hmm.
So we still need people to actually do these things, and many things that these things tend to automate is, like as I said, some repetitive things. So something that it's fun to do a few times, but then if you do it for the 10th time or 20th time, it's a bit boring. So it's actually a good thing that we have these tools now to make us more productive.
Okay. And if I'm hearing you correctly, maybe some areas, like if you're not aware of the landscape that's kind of out there in order to be an effective machine learning professional working with models and production and that sort of thing, like does it make sense for that person to basically maybe focus a little less on like particular models because we have the auto MLs, and maybe focus more on like learning about the business and also like running things in production? Is there like special knowledge that you recommend that we kind of get by running in production or machine learning models in production?
Yeah, of course. So like you have some assumptions when building a model. You think this is the model we'll bring, but once you go to production, all of a sudden the users start behaving completely different, and then you learn a lot of actually what people need, and then you try to adjust your model. So there's a lot of learning after you go live with the model. That's learning part about user behavior. So that's one thing. Some things you didn't anticipate, they happen. So people use the product in strange ways. And the other thing, of course, going to production often means like a lot of load, especially during peak hours, and then watching how your system can deal with this kind of load. So this is more technical. Also is a lot of like a lot of learning. So you learn a lot by just going live and seeing how model reacts, and then trying to tweak it so it doesn't go down on every million users, and it still stays there and still be able to serve. So this is more like a traditional software engineering work. The only machine learning component there is just the service you have is a machine learning service, a model. But still, you need to learn a lot about like how your service should be able to sustain this particular workload of the traffic that your users generate. So this is a lot of useful learnings as well.
Okay. Yeah. Thanks for sharing that. And I was curious, how did your early days of IT and kind of your background in databases, how did that set you up for your chosen path as a machine learning expert?
Yeah. So I'm from a small city, like in the far east of Russia. And the only university there was a pedagogical university, so studying to become a teacher. But there was one faculty where, for some reasons, they were teaching databases. So I thought, okay, I should go there. So it was somehow outdated. I was still learning how to do Delphi and all these things. So like it was in 2006 when I started. So it was for that region, it was what it needed, but for the rest of the world, it was a bit outdated.
Mm-hmm.
But somehow, like we learned how to deal with databases, all the SQL stuff, how we need to design databases, how we need to automate processes. That was fun, but one of the subjects I really enjoyed was stats and math and all these things. But there was no way to apply these things. So because everybody just needed a database, like in Delphi. But then eventually I moved to a bigger city in central Russia. And there I realized that people don't really need Delphi. They need Java, they need web services, they need something more interactive. But still, at the end, it's a database, and then just it's web service that goes to database. And then around 2012, there was like Coursera became popular, and one of the courses there was machine learning, and I happened to watch that course, and this really changed my life. So I understood, okay, this is Java is fun, databases are fun, but this is really the thing I want to do. So because I really, during my studies, I really enjoyed doing like all this mathematics, statistics. I should really go this way.
Mm.
And during around that time, positions in data science started to appear as well, in small amounts, not like now, but just a couple here and there. Back then I lived in Poland. And there were in Krakow, and there were a couple of positions already there, but all of them required like PhD, so like experience in Hadoop and things like this. So it was really tough to get in, and companies also didn't understand what they want from data science. They just heard, okay, there is this machine learning thing, data science is also a thing. Let's hire somebody with PhD and figure out what we need.
Hmm.
Yeah, so it was really tough to switch from Java to data science back then. So I decided, okay, maybe I need some education. So I did the master's. And in the meantime, I also worked remotely, also doing some Java, but for machine learning. And then when I graduated, all of a sudden, they didn't need PhD anymore. The market figured out what they actually need from data scientists. So they understood that PhD is a nice to have thing, but not a must. And since then, it's only growing, the demand for data science and machine learning engineers. And for me, what I found out is having background in software engineering is super helpful, because at the end, you have a model. But now you need to do something with this. You need to go to production. And this is the part where many data scientists struggle with, because they know how to read papers, they know how to implement things, but going to production is difficult. So that's why I think having some experience, some exposure to software engineering is extremely helpful for data scientists to actually make use of these models and then solve real business problems by productionizing the machine learning models they trained. So this is, and I also noticed that many companies are looking for this kind of people, for software engineers who know a bit of machine learning, maybe not super in depth, but enough to actually to train a model and make good impact. Because with the skills of software engineers, they can train a simple models and then actually make impact by productionizing, integrating with existing services, and then making customers happy.
Yeah, that's an interesting insight there. So a little counterintuitive, I guess.
Yes.
But
So I
yeah.
spent so many time trying to go in depth into math, and then at the end it turned out that it's not really that needed. It's fun. It was fun to really understand how these things work, but actually the job I'm doing, the job many of my colleagues are doing, they don't involve solving math equations. They just take a library, take a data set, I'll spend months preparing the data set, then take this data set, then throw it into library, wait for 10 minutes, and then have a model, and then productionize it. So that part of machine learning, it doesn't take a lot of time, yet the focus of many programs in universities and online courses is on the mathematics behind. This is, I think, still somehow needed to be able to understand what's going on, to the same extent as software engineer probably should know how TCP works, right? But not many software engineers actually need to go deep into all this TCP stack to on everyday basis, right? Maybe once in 5 years there is some problem that really requires going deep, but day-to-day work typically doesn't. And I think the same happens in machine learning. So typically you need, you just need to have broad knowledge, good exposure to different techniques, but maybe knowing all the details maybe aren't helpful. Just a bit of knowledge, just a bit of indication how it actually works to be able to explain when something is not right, to be able to understand and debug perhaps. But maybe going deeper is only needed when you face this problem. Not like I did. I tried to understand all in advance, and then it turned out to be not needed. And instead, maybe I should have focused more on hands-on things and then dig deep when it's actually required.
That's seriously, this is the reason why I do the podcast, because you have mentorship figures like yourself that are like, hey, there's 1,000 ways to do this, but if you want to have like any kind of quality of life, this is the path you go down. So you're like a huge proponent of like, maybe get some general knowledge. That's not going to be a waste, but if you're somebody that gets in the weeds with things, like, don't let yourself go down these rabbit trails. If you're trying to make money with your skills, you just need general knowledge and just focus on just put whatever it takes to put it in production is kind of what I'm hearing.
So T-shape, maybe, or T-shape skills.
T.
When you like T is like you have like a bunch of skills, and then you have the breadth of these skills.
Okay.
And then T is like you just touch a few subjects, but not a few, like a bunch of them, like many of them. So it can be productionizing machine learning models, preparing the data, backend services, maybe front-end services as well. Like all these kind of things that we have around us. Just to know a bit of them, like for example, how to go ahead and create a simple React app in JavaScript. This is super useful, but maybe you don't need, as a machine learning engineer, you don't need to go really deep into understanding how React works and how to make front-end applications as a professional front-end engineer. But just having some exposure is helpful. But then you specialize in some particular thing, for example, machine learning, and then you have sort of this T letter. So T, when T goes down, this thing goes down. This is the breadth in one particular area. And then the thing at the top is like breadth, like knowledge in different areas.
Yeah, that makes
quite shallow. Yes.
Okay, that makes sense. So if I were to just dig here a little bit, what would be the depth that we should be seeking as machine learning engineers? Like, where's our time best spent going deep, would you say?
So I think it all depends on what you like, because what I think is really helpful for a company when they hire people is that the T part that goes down for people is different for everyone.
Okay.
So then this like diversity of skills. There are people who can do, who can quickly go through a paper. Perhaps for some companies it's important to still be able to understand. But then for some people it's actually just take this and productionize this. For some people it's about making data pipelines. So this is data engineers who make sure that the data is processed reliably, and then all kind of like it's called ETL, like you take data from somewhere, process and store it, and make it available for machine learning services to consume. And if this T is different for people in the team, what team can do, like basically everything. And if in some parts maybe there is no expert in the team, they still have some shallow knowledge to dig deeper and then solve the problem.
Yeah. Dang, that's a cool concept. As you were describing that, I was thinking about things at work because I come from a similar background of databases. Like that was my first taste of the data world. And a lot of my work, I see myself going back to the data engineering side. And but ultimately it's like, what can we do to support that mission of getting these things into production? And if I'm the database guy and there's like a Linux guy that's doing DevOps, like these are good teas to have on your team. So
yes, especially with DevOps, this is often a bottleneck in teams that I observe, and that one thing is creating a service, and then other thing is actually making sure that the service is reliable, auto-scaling, and all these things, and then have proper alerting, all these things around the web service that makes it production, to make sure that all the responses within I don't know, like 10 seconds, so like it doesn't exceed this time, so it doesn't go down, all these things. This is something that DevOps people or software, I think it's called reliability engineers.
reliability.
Yes.
Mm-hmm.
So these people are super helpful for teams, and they are very hard to get. And if these people now decide to learn a bit about machine learning, then they all of a sudden become super valuable for companies that want to use machine learning to make lives of their customers better, because they have these unique skills that make software reliable. And they also know a bit of machine learning to actually understand what's going on. So this is super helpful to have this background nowadays.
Yeah. Dang. Yeah. Thanks for allowing me to open up that can of worms. That was good information. I was curious, what was your first success as a machine learning professional?
So first success.
Mm-hmm.
So, well, I guess when I was a freelancer, typically I would implement some things like train a model, and then what was pretty frustrating for me that I didn't see what would happen with these models. So it was just, okay, here's a model, use it, and then they would say, yeah, thanks, see you, and then I didn't know what was going on with the model. So when I stopped freelancing and started doing a full-time job, then I started having real projects that like working on product instead of consulting. Then I could see things end to end, and this is where I started to observe positive output of the models. So like these successes, and then it was in a company that was doing search engine optimization. That was the first company where I worked at full time as a data scientist. It's called Search Metrics. So they are doing search engine optimization. And one of the things they were doing was helping copywriters. Copywriters are people who need to write blog posts. So they are basically marketers. They want to get the company where they are working for a lot of exposure on the internet. So they go ahead and write as many articles as possible. So these articles get indexed by search engines, and then when people look for things, they pop up, and people read these articles and then end up on the company's website and buy things. So for these copywriters, the task is typically, hey, you need to write, I don't know, 1,000 words on this topic. So this is the topic, do your research, and then come up with an article. The typical workflow of copywriters is go on Google, type the query they want to optimize for, they want to create an article for, and then understand what are the results are, what are the top 10 websites, what they write about, what are the topics they cover, what are the things they discuss. And then they analyze this, do some research, and then they come up with a new article that sort of reflects what is already there that Google picked up by this keyword. They try to produce something similar, And the idea is, if Google found the other articles useful and valuable, so they ended up in the top result, this new article also would end up in the top results, the first page, for example. And this is actually working. So this way, copywriters can produce content that ends up in top pages of Google. But there's a lot of manual work. So these people, they need to really do some research, like understand what are the important keywords that need to be mentioned, what are topics that need to be covered for this particular keyword. So the project I was doing was actually trying to help these people to make their job easier, to instead of them going through all these pages from Google, we would do this for them. And then here are the keywords that you should use, because 10 out of 20 websites use this keyword. So for example, if you write about New York, then maybe word Manhattan should be mentioned, or Times Square. And Times Square is 2 words, not just 1 word. So this is like a collocation, because you have 2 words, but they mean one thing, a particular thing. So trying to extract this, trying to understand what is helpful, what needs to be mentioned. That was the project I was doing. And it was at the end a great success, because the companies, the clients of Searchmetrics started to use it, and they really liked it. So they saw that indeed helps the copywriters to create content faster. So this was a very exciting project for me, because I really liked working with text data. And also at the same time, not just creating a model and then forgetting about this, like it was in case of freelance, but actually taking end-to-end responsibility from the beginning of the project to actually deploying this, seeing how customers interact and trying to tweak it, and then making it better. This is really rewarding to watch and do. And this was one of the first successes. Of course, there were some other projects that didn't go really well for different reasons. Sometimes it just happens, and either we decide not to focus on something and not to continue working, or maybe perhaps it doesn't get any traction and customers don't use it, and then the project just dies. Or we realize that we do something, but it's not needed. Also, it happens a lot in software world. So unfortunately, there are cases where the project is exciting, but then it doesn't really have any impact. But luckily, there are those projects that do make impact, and this is really cool to think. And now for me, it's a good memory. It was 4 years ago, and I still remember about this project as if I did this yesterday.
Yeah, that's a really cool story. Basically, like anybody out there that's trying to come up with like something that would work in the marketplace and actually make money, with your skills, like that's a really cool concept that you just brought up. I could also argue it's like a career path, like becoming an expert. So how did you kind of manage with, I mean, it was a good experience. You're not doing it anymore, but you got some things out of it that you were able to build on top of. Like, what is your, like, because immediately is that when I hear that story, I'm like, dude, why didn't you just keep doing that? Like, that sounds awesome.
Yeah, well, at some point, like it happens when people change companies, they realize they're maybe not learning enough, or maybe the environment is not best for them. So it also happened to me. So then before settling in at OLX, I was in a few companies. So first was Searchmetrics, then second was a small company doing mobile advertisement, so also marketing, but from a slightly different angle. So it's advertisement in mobile apps. When you play something, you see these annoying things. So maybe one of them was because of me. So, but then, yeah, I eventually ended up at OLX, and OLX, maybe many people don't know, this is online classifieds platform. So it's like eBay. Well, on eBay you have bidding, but this is a place where you want to sell stuff you don't need or buy things you need. So like in the States, I think Craigslist is the best example. I think it's still one of the most popular online classifieds website, even though many people will think it's not super modern. So I think the web design is still from 80s or when it started.
But business is happening there.
Yes, business is happening. So this is, I think it's still the most popular online classifieds platform in the world. So and OLX is still in top 10. Maybe it doesn't have the it's not Craigslist, but there are some markets where OLX is present. So not in the States, but for example, in Poland or Ukraine or India and a lot of countries. Actually, it's 20 markets, I think, where OLX is present. Yes, it's pretty global. In some markets, OLX is present under a different brand. So, for example, in Russia, people know it as Avito. It's also quite large online classifieds. And then in online classifieds, there are many things that machine learning can solve. So one of the things when I started working at OLX, the first thing I was working on was determining if quality of an image is good. So people often want to sell something and then they don't realize that taking a good picture is important if you want to sell something. Of course,
wait, it is or it isn't?
It is. It's very important.
Okay. Yeah.
Yes, because people want to see the thing before deciding, okay, well, do I want to contact the seller or not? Although sometimes if price is low, the quality doesn't really matter. But if price is not that low and then picture is bad, then people don't contact the seller. So we wanted to help them to say, hey, perhaps you need to do this in not in the complete darkness or not with direct sunlight or something like this. So just to educate people like how they should take pictures to increase their chances of selling things. And this is where machine learning was helpful to analyze images that, okay, there is too much sun exposure, for example, or it's too dark.
Like you're critiquing them on like how to make the picture better and their photography. Is that
maybe is a strong word, but yeah, like just saying them, educating them. So for example, if they want to sell something and then after 2 weeks nobody contacted, then we think, okay, maybe perhaps it's because the picture is bad. Let's analyze the pictures. Yes, indeed, this picture is pretty bad. So then we sent a campaign, like a mail to the seller. Hey, please consider retaking this picture because in this picture there are these problems. So for example, the object is not properly centered. It's too dark, it's out of focus. And then here is an instruction how a good image should look like. And then after this, people would, some of them, not everybody, but some of them would actually follow the advice, retake pictures, and then we would see that indeed the number of contacts these people started to receive was a lot higher than people. The buyers started to be more interested in the items. That was one of the first projects I worked at OLX. And then other thing in online classifieds, pretty important, is content moderation. So people can, you cannot even imagine what people try to sell, or like some illegal services or weapons or drugs or
just scammy stuff. Or
scammy stuff, of course, yes, like a lot of fraud. And typically what happens, there is a content moderation platform and content moderation team that looks at the content that users publish and reject things, saying, hey, this is not allowed to sell here. You just ban the ad to the users or try to educate it when, for example, in not serious cases, like when maybe somebody was trying to sell a cell phone and put them into cars category. Hey, the category is not right. You should put it. So like there are innocent cases, but there are serious cases of fraud where people, for example, steal images from a good listing, then they pose as genuine sellers, saying, "Hey, this is a flat I'm trying to sell, or this is a car I'm trying to sell, or this is a cell phone I'm trying to sell." And then somebody contacts, a buyer contacts, and this fraudster tells, "Hey, yeah, but in front of you there are 10 other people who also want to buy this cell phone. But if you give me $100, I'll set it aside just for you." And then some people do give $100, and then the fraudster disappears. So this is scamming, and want to prevent this from happening. And this is what the content moderation team does. And there are a lot of things where machine learning can help. So for example, one of the projects I worked on was detecting duplicates. This is exactly the case when somebody copies existing content and tries to pose as a good seller. So this is the case where we can detect with machine learning. Or maybe this user has other accounts, and by looking at the behavior of these accounts, like where they come from, what are the IPs, what time of the day they come from, so we can somehow cluster these accounts and understand that they actually belong to the same person or the same entity, and then we can band them together at once. So there are a lot of opportunities to actually use machine learning to make the job of moderators easier, because moderators need to go through a lot of content. We want to help them to somehow show them, like, okay, this is fine. You don't even need to look at this because this is just a pair of socks that somebody wants to sell. So this is innocent. So we don't even show this to moderators. But in some cases, hey, this looks like a gun. Please show and confirm that this is indeed a gun and take an action, like remove the gun from the platform. So this is actually content moderation is the place where machine learning started at OLX. So this was the first successful use case of machine learning. It was indeed valuable, and then from that team it started to grow, and now machine learning is everywhere in all the teams. Not all, but most of them.
It was kind of their gateway drug to, like, okay, we need to be anybody with like a manual process, or if they feel like like everybody's leveraging this technology and they're more effective at their work, which I think is just my experience doing these podcasts and talking with people. It's like there's a lot of fear around this technology, but it's actually improving our ability to live life at its fullest, or whatever quality of life at work, like whatever you want to call it, right?
Yes. So one of the metaphor one of our project manager used is our moderators are pilots, and like when you're a pilot and you have a plane, most of the time there is autopilot that takes care of the plane. So this is machine learning. So machine learning takes care of your job for you, like of these cases where no human involvement is needed. But when human involvement is needed, then the actual pilot of the plane takes care of things. So the same is with machine learning. When machine learning is not sure, the model says, "Hey, moderator, can you please review it for me and confirm that there is indeed a gun?" So it takes care of these easy cases of innocent things. So it tries to automate things, but in uncertain cases, then we try to involve a human, just like pilots.
Yeah, that's a cool metaphor.
Yes.
Yeah, I might even just use that going forward as my metaphor. Cool. Thanks for sharing that. So I was curious, so you're writing this book right now. So and you're kind of like you understand very well, like if you're going to produce content, you go research what people are looking for right now. So what patterns did you see in the market's needs that triggered your idea for writing this machine learning boot camp?
Yes. So first of all, so I wrote another book. It's about Java and doing data science. So that was maybe not. So it's pretty niche. So there are Java is not really that popular for machine learning, not that widespread. So then I realized then, okay, Java is cool, and my background is mostly Java development. Previously, now I'm using Python mostly, but previously it was Java, and I thought, okay, I should try to fill this niche and write in a book about Java and data science. But this niche is pretty small, so people in general are like, the trend is now is Python is the language of machine learning. So if you want to do machine learning, you use Python. You don't use Java. You don't use, I don't know, other languages like Scala. Okay, there is maybe, I don't know, 0.5% of people who do these things do use Java, but the majority, I don't know, 70%, they still prefer Python because this is simple. There is a great ecosystem of things, good support everywhere. So I thought, okay, so I still have some things that I want to share with the world, but the world is not interested in Java. So let's write another book, this time in Python. And then the concept of doing this by project, this is something I learned at Kaggle. Kaggle is a website where you have data science competitions. So some company prepares a data set and then asks people, the community, hey, we have this data set, can you train a model for us? And this is very hands-on. So you can train a model, you immediately see feedback because there is a leaderboard. You have a model, you score the so-called test data. This is the data for which you don't have, you need to generate predictions. You upload these predictions on a platform and you see how well your model is doing. So you get feedback immediately. So this is really hands-on. It's really like a lot of coding. Like you just create a model, you try to optimize the metric that you have in the competition, and then you submit your solution and then see how it goes, how it does. So this is a lot of projects. So like each competition is a project. And for me personally, this is when I learned most. So years at the university helped me to learn theory, but this theory without actually practice wasn't that helpful. And to be honest, wasn't that needed to do these competitions. So because these competitions are really hands-on things. You just take a library, you apply, you try to tune parameters. You take another library, you try. You have this idea, you try this idea. So it's a lot of engineering work. Just you have an idea, you want to code this idea in Python or whatever, and then you test if this idea works. And this made me realize that the best way, at least for me, but also for many other people on Kaggle, is to actually not just study a textbook, but rather do things. Just get a data set, get my hands dirty, solve this problem, and then try to understand what is going on there. And then it was a lot more helpful for me than just watching like all these equations solved on a blackboard. So that's why I think that this project-based approach is the best approach for people who are software engineers who can code. And that's why I wrote this book. So first of all, it's Python, because I think Python is the lingua franca of machine learning. And then it's project-based approach, because I think for me personally, and many people agree, that this is one of the best ways of learning machine learning.
Yeah. And actually, so just hearing what you were saying there, it's almost like because I've worked with those Kaggle competitions before, and there's certainly a lot you can learn just by seeing other people's work that they submit, and you're like, oh, everybody's upvoting this. I wonder what their methodology is, and then you can kind of learn from that. But there's still no like video tutorials or something that you can watch on these data sets. So one might be able to argue, like, if you are trying to perform better as a Kaggle competitor, for example, your resource the book that you're writing is almost like built on the pains that you had going through this process. And so you're kind of like, this is going to be a resource that's going to help you compete better. It's going to help you get jobs, like a portfolio for your jobs. Like, am I kind of understanding this correctly?
Well, more for jobs than competition, because competitions are very helpful also for doing jobs, but they are pretty specific in a way they are designed. So at the end, if you want to do well in competitions, you go an extra mile. You do some things that you wouldn't do on your daily job. So the book is not about teaching how to perform well in competitions, but rather how to use the knowledge that I got from competitions and from the work I'm doing, and how to apply this knowledge to be a good to be a good machine learning engineer,
Okay.
to actually solve business problems. So for learning how to compete, there are other resources. I don't know a book about this, but typically this is, for example, forums of Kaggle. So this is, if you want to learn how to compete on Kaggle, you just need to compete on Kaggle and then read forums. But yeah, so this is more targeted for people who want to do well on the job.
Okay. Yeah. And that's at the end of the day, like we're trying to get these skills. We're trying to get paid. That's the mission here.
So Kaggle is fun. Kaggle is a lot of fun and a lot of learning. But then, as I said, some things you need to do there in order to be competitive that you wouldn't do on your daily job. So like one of the examples is building an ensemble of models. Ensemble is like when you put many models into one big, huge model. And this tends to improve the score a lot on Kaggle. But this is something you wouldn't do in real life on a job, because like if you have 100 models, then you need to maintain each one of them. So like it should be a reliable service. It's just too much overhead. So you don't want to maintain 100 models. You probably want to maintain one model that does well, instead of maintaining 100 and then also try to ensemble it into one super model. So this is where Kaggle is different from real world. But the learning, like each model that you train on Kaggle, how you train it is quite useful for real work. But maybe this last step of ensembling is not, and there are some other tricks that you wouldn't do on like in real life. So of course the book doesn't cover them, and there are other resources that cover, but mostly this is knowledge you can get by participating in competition, because people tell them, oh, I do that, and this helped to improve my score.
Yeah, it seemed like a cool community. Like it's very
yes.
collaborative, and like you might have like the highest performing score, and you go to bed and you wake up in the morning and you're like position 10, like
yes.
if things are moving, it's like, it's almost like a video game. I don't know. It's interesting.
And it's very addictive. So if you if you have some time and you want to spend somewhere, Kaggle is a very useful way of doing this, but just be aware that this is super addictive and it can be very difficult to stop doing Kaggle.
Yeah.
So be aware.
Good to know. Yeah,
yes.
that's good to know. I wanted to, okay, so you kind of alluded to this, like the difference between Python and JavaScript and why you kind of like went that way. And I noticed on your CV, you had mentioned that one of your gifts that you bring to the world is that you are good at rapid prototyping. And so I was wondering, where do your rapid prototyping skills get applied most often? I'm just curious, like,
yes,
is it everywhere, or, is it very specific things that you find that working?
Well, for machine learning, but also for other software engineering products, it's important to somehow validate them as fast as possible, often without actually coding anything. Like just, for example, imagine like the example I used previously, like imagine we want to build a system that tells if an image is good or not, right? So if it's framed properly, if light exposure is good, if contrast is good, or focus is good. So instead of investing time in building a model, what you can do is just sit there, look at the pictures, and then say, okay, this picture is not good. Let's send a mail to this seller and see how they react. So instead of investing into building the whole thing, just take some manual effort to validate this thing is actually worth building. Test it with the users, see how they react, if it's something they actually need, if it's something is helpful for them, and then invest time into learning. This example was a lot of manual work, so just look at things yourself and then maybe have a spreadsheet with, okay, we should send this user in email. But of course, you can also automate this and build something simple. Or maybe just have a simple Flask app in Python that maybe doesn't always follow the best engineering standards. Maybe instead of having proper models, you have just one, like your main.py. But you, as fast as possible, you want to validate something, to see that this is something users want, or this is something that other stakeholders in company think that they should invest on. So maybe we should convince not the end users, but first the decision makers who decide which project to work on, which project to invest money in.
Mm-hmm.
And then to convince them somehow, the best way of convincing is not a PowerPoint presentation, although it also works. But what works better is a prototype where they can actually click on things. They see how it works. And this is what I mean by prototyping skills, to be able to, as fast as possible, to have a thing that works most of the time and can be used to convince people that we should indeed invest time into making it a proper service, or making it a proper model. So it means starting fast, and then also failing fast, because often these decision makers say, okay, this is not what we actually meant. We don't need this thing. And it's very good to learn this feedback as early as possible. Because if you invest half a year into building things that they say, no, we didn't actually mean this, it's painful.
Mm-hmm.
So rather, we should validate what they want as early as possible, like maybe in 1 week.
Yeah, man. Okay, so first of all, like we're about an hour into this. I feel like I've gotten my money's worth out of this. Like what you're talking about is seriously, I don't know if it's just like the stuff going on at my work right now, but like this is so critical, and we are practicing this right now, and it's so exciting, I think, to know, okay, in a week we're going to know if this thing even has a future or not.
Mm-hmm.
And sometimes it's almost like a culture thing. Like if the company culture, I don't know, it's very intuitive to me, but you talked to me a year ago, I don't know if like rapid prototyping is something that I would seek out as a skill on my team, or even to build on my own. But holy cow, it sounds like it's one of the most important things that you can develop.
Mm-hmm. So for me, maybe you heard this expression. I'm a really fan of this. So first, make it work, then make it right, and make it fast.
Okay, I love that.
Yes, and I think it's attributed to Ken Beck like 20 years ago. So he said that. Well, he meant actually in a slightly different context than what I'm talking about here. But I really love this expression, and I try to use it when possible. And some companies, indeed, as you said, they have a value that says, yeah, move fast. Like Facebook, maybe you heard like move fast ratings. I don't know if they still have it as a value, but at some point they used to have it. Like, okay, let's move fast and then learn as much as possible.
Mm-hmm. Yeah, that's a really cool framework to operate from. What do you have? Maybe we already covered this, but just like off the top of your head, what are like 3 tips you have for someone to become an expert at rapid prototyping?
Well, just maybe time frame. So let's say I want to spend on this only 5 days, and I want to do as much as possible during these 5 days. And then like just hackathon-like mindset. So just try to squeeze most out of yourself, maybe get some people to also work on this, and just move fast. So time frame, and not let it take more time than initially. So just 1 week and then it's hard stop. And I think it really helps to think in this way. Okay, I only have 1 week. What is the most important thing I need to focus on? like, okay, maybe I don't need other things. So let's concentrate on this one. Let's have this particular thing working. Let's have a demo that showcases this particular thing. So it helps you also to understand what is the most important thing and work on that instead of, building other things.
Mm-hmm. Dang. So there's no more tips. Like if you take that one and put it in the bank, you're good to go. Or do you have other tips?
Well,
I mean, that's good enough. Like I feel
one
like
tip, right?
yeah, I mean, that's my money's worth right there. No doubt. But I want to pry a little more. That's part of the fun with the podcast.
Yeah, so maybe instead of using Java, use Python. So
Mm-hmm.
it's a tip because Python lets you move faster. In Java or any other language where you have static system, like static typing system, they in the long term, in the long run, they maybe you can have more reliable software because compiler also helps you. But when you just start and when you move fast, sometimes it doesn't let you move like with the speed of thought. And Python is better for that because it's so interactive. You can just have this wonderful thing, Jupyter Notebook, and then just play it there and then copy this thing and paste it into a Python file, have a Flask service, right? In Java, that would be quite difficult to do. And for me as a Java developer, ex-Java developer, for me, the concept of Jupyter Notebooks was super unnatural. So I was really struggling to start using them. But once I did start, there was no way back. So I think just using a language that like Python with all these wonderful tools, I think it really helps to move fast. Then I'm struggling to come up with a third tip. Maybe just have people who also want to help you. So not do this alone, but time box and then have a few people to help you. Because I also noticed that sometimes people do this alone. Like, okay, let me just close myself in this room for a week and then I'll have a prototype. Probably trying to involve other people is a good idea too.
Dang, man, that's powerful. I mean, dang, there's so much gold there. Like, yeah, one of you practicing this, okay, that's maybe you can be productive. Mm-hmm. But like a group of like-minded people, like that, what do they call that? Where it's like 1 + 1 = 3 type thing. Mm-hmm. It's like I see your message is solid, man. Yeah, thanks.
Although it can be difficult,
yeah.
I think in some cases to like for me as a software engineer, maybe I don't always have this mindset of like a manager, like being able to delegate, explain things properly. Because for example, in my head, I can just sit and implement this, and when I have to explain to somebody, it makes things very slow. But I think practicing this is very helpful for any software engineer who wants to progress in career to make to the next level. So I think this hackathon is a very good experience to like to have this, to gain these skills of translating your idea into clear message so somebody else can pick up this and implement. And this is very difficult. I also realized myself that in my head I already have a solution, but I don't always know how I arrived at this solution. And helping to unwrap this into, okay, how did I actually, why did I think it should be this way? Okay, and then having like somehow having clear path, like clear steps how I arrived at the solution, and then explaining the steps to other person. This was also really helpful for me, and this is something I also learned at one of the hackathons.
Dang, that's powerful. So one last part on this rapid prototyping, I must know. Okay, so you have maybe like every year you set your goals, and you're kind of like, okay, 6 months from now I want to be here, 9 months from here I want to be here. But if you're practicing this rapid prototyping and you're setting yourself to maybe like a 5-day hard stop or a 15 or 30-day hard stop, how do you, like, my intuition tells me that it's good to have long-term goals, but you probably learn so much through that process. 6 months down the line, you realize how delusional you were with like what was appropriate goals, 6 months out. How do you deal with that? I'm curious now, man.
I don't know. Sorry. So this is the same problem I have every new year. Many people like me also decide, okay, this is the best time to have New Year resolution, right? And then okay, I see it for 1 hour, 2 hours, and then come up with a plan. And maybe I try to stick to this plan for 2 weeks, for sometimes, and then I forget. And then 6 months after that, I suddenly discover this list, and then think, was I that stupid to put this as a goal? Like, why did I do this? So I don't know. Just somehow things happen, and then just try to stay with them. So I don't know. I don't have an answer.
Yeah, that's kind of like, what is the like the answer to life or something like that. Maybe that's what that question was. So you did well. You okay, cool, man. What do you recommend that does not take too much effort but solves like 80% of the challenge of becoming like a Kaggle competition winner?
Okay. Well, there is no easy answer, unfortunately.
Okay.
So to me, it took half a year of active participation to actually end up in top 10. And this is not even winning money. I was fifth, so only top 3 win money. But actually being like ending in top 10 is super difficult. So this is recognized in the community as a sign of. That's why they have this Kaggle master sort of page, saying that this person did well in this competition. So this is a recognizable thing. And unfortunately, there is no easy answer but practice. And for the competition that I did pretty well, I started from the beginning, and then it lasted for 3 months, and almost every day I did a little bit. So just read forums, see what other people do. Try to also to not get too behind. Try to reproduce what they do. Maybe generate some ideas. Pick the most promising one. Try to implement this. And also, I think sharing some things on forums also helps, because this creates this community that if you share, people share back. So when you discover things that really work and give you competitive edge, it's still helpful to to share these things. So because then others will share back some other insights. So it's really helpful for a career. It was helpful for my career to spend this half a year on Kaggle. And try to do well there, because it's immense amount of knowledge there, but it's also a big time investment. And then at some point I realized I'm spending too much time on this. Let's stop. But probably the best way of doing this is read kernels, try to understand it. And kernels are often written by not professional software engineers, and trying to understand them is often difficult. So, but still try to figure out what's going on in this kernel and why it works. And then also try to read forums, and then it should help you maybe not end up in gold, but with a silver medal perhaps, which is still a lot of experience, a lot of you would learn a lot of things.
Yeah, thanks for sharing that. So I prep out some framework for the questions of the podcast, and then I kind of go on these rabbit trails as they pop up. But after I wrote that question down, and as far as our conversation has gone right now, I actually I like the answer that you gave. I think there will be an audience that wants to hear that message, but I'm actually more genuinely interested in, like, I think based on what we've talked about, it's important to get a job with your skills, to get paid for your skills. So I actually, if you'll let me ask like almost the same question, what do you recommend that does not take too much effort, but solves 80% of the challenge of basically convincing somebody that you are a good person to hire as a machine learning professional? Or,
So, well, first of all, buy my book.
Of course. Projects.
Yes,
Yeah.
yes, projects, of course, yes. So one of the things I think are super helpful uh, is build a project, but then also get noticed. So if you have an idea, find a data set for this and try to implement this idea. If you don't find a data set, try to build your own data set. This is difficult, but if idea is cool, then it's totally worth it. So so build this data set. But then also, like once you have this, once you train a model, don't just don't let it just sit there. Let the world know about this. So put the code on GitHub, um, write a post on Medium or any blog post. Then try to use social media to somehow tell the world, hey, there is this piece of content, please have a look, and create awareness about yourself. And then I think if you do this like for 10 projects, you'll get noticed for sure. Like, especially if you post somewhere like Hacker News or some places like that.
Yeah.
And there are a lot of people who are interested in this type of content, especially people right now. Machine learning is a hot topic. And when you learn it yourself and then also try to teach others, there's a lot of people, there's a big audience of people who want to also learn from this experience and also try to reproduce this project. And for them, it will be very helpful, and for you, you'll get noticed.
Okay. That's really solid. Thanks for sharing that. What do you think is overly difficult to master with machine learning that newcomers should kind of just completely avoid?
Well, probably at the beginning, people should avoid going too deep into theoretical foundation, especially with things like support vector machines, or there are some certain algorithms that have a really solid theoretical foundation, but at the same time, it requires a lot of knowledge to actually to be able to understand it. So these support vector machines, for example, require a few years of calculus and I don't know, a year of uh, how it's called, convex optimization. So like things that are pretty difficult and advanced, and people study them in like third, fourth year of university. People who major in math, for example, or applied math. So this is pretty difficult, and it might give you a sense that I don't understand anything, so let's quit because it's not worth my time to like. And people, when they see these equations, they're super difficult, and then just give up. People give up.
Mm-hmm.
But don't let these equations carry you.
Right.
Because there are libraries that you often don't need to be afraid of what's inside. You just need to be able to use them. Like a metaphor I used already. Like you don't need to know how TCP IP stack works to be able to create a web service, right? So of course it's helpful, but for a newcomer, certainly focus should be on I don't know, learning Flask rather than going deep into the OCI model. So I think the same, to just stay at the problem, like at the right level of abstraction. And for the beginners, it might be a library. And then when you need to go deeper, then maybe then you go. So don't try to peel the onion from the start. Maybe just stay on the top first, and then when the time comes, then maybe you dig deep and try to go down these abstraction levels.
That's all. Yeah, that's awesome. Don't try and peel the onion all at once.
Yes,
that's
yes,
awesome.
yes.
There's so much wisdom, in that. Holy cow. Okay. Yeah, I love the whole like even with your prototyping methodology, it's about this like being incremental, seeing if it works, and super dynamic. Like I know I asked you like, what are your morning routines? You're like, whatever I need to do. I'm pretty adaptable to like whatever needs to be done. And I think that's the name of the game, man. Like what you're like the real core of your message is like, just, focus, realize that you have these tendencies, maybe that you might try to get into the weeds or whatever, but just be proactive on not trying to peel the onion, be incremental, or not try and peel the onion all at once. So that, seriously, man, I'm resonating with your message here. So thank you. Let's see here.
Welcome.
Let's see here. Okay. So what is the easiest way for someone to start integrating the promises of auto ML or auto machine learning into their workflows? Like, how can we do that starting tomorrow?
Yes, so AutoML, this is we already talked about. So this is like the thing that takes off the load from you of training multiple models and finding the best one.
Mm-hmm.
So to use them, you don't really need much. You can just, for example, if you already use scikit-learn, you can use a library that is called AutoScikit-learn that basically just tries to find the best model. Or there are some libraries like Bayesian optimization libraries that let you find the best parameters of your model. So this is something also to explore. And then finally, there are companies like Google, Amazon, Microsoft that have their clouds. And in the cloud, in their cloud services, they have a special service. I think most of them have these three for sure, and then other smaller cloud providers also. There is AutoML, and then you just have a data set, upload this data set, and then this thing figures out how to deal with each type of data, each type of column that you have there. Like you upload a CSV, and then you also need to specify, okay, this column is the target. This is the number or the category I want to predict. And then it figures out what to do with the rest. It trains the best model, and then it says, okay, this is the model. You can use it either in our services, or you can download it and use it on your own. And then I think this is the best way is just to go there to your favorite cloud provider and just try to play with what they offer and see, actually learn and observe how easy it is to use these things. And this is one of the other things I mentioned that I enjoy seeing it as a trend, is that machine learning becomes a commodity. A lot more people can start using it even without having a proper mathematical background, like having a PhD in mathematics or physics or like some other complex subject. But simple people, mere mortals, like somebody who can code, can already benefit immensely from these services, these libraries, and can go ahead and serve to solve real business problems and help their businesses grow.
Yeah, so the ecosystem is kind of matured to a point where there is no excuses. Like you can get out there and get your hands dirty and solve real world problems, and you don't need to be like some PhD genius. Like there's no excuses. If you want to get your hands dirty, you can. That's kind of what I'm hearing.
Yes, exactly.
Cool. Yeah, thanks for sharing that. What are 3 key learnings from your experience running machine learning models in production?
Yeah, so go as fast as possible. So try to deploy a model as quick as possible, because one reason of project failure that I saw was spending too much time on making the perfect model. Don't make the model perfect. Just have something super simple, like a simple baseline, and then try to deploy it. Try to move with this prototype in production, like with this baseline in production, and then see how people react to this. Don't make it overly complex. Just as simple as just take some category and then compute mean within each category. Like for example, if you want to predict a price, for an item, then just look at the mean price, at the average price in each category, and then just use that as prediction. So something super simple. You see that all Audi car of this particular model, like on average, have this price, and use this as price suggestion. Don't make a super complex model like a neural network or something. Just go with simple things first. Try to deploy that first. See how users react to this. See if they actually use it. If they don't, stop. Because like after investing a lot of time in a machine learning model, any project, that's maybe another learning, that people tend to have difficulties stopping working on a project. You know, maybe you heard about this IKEA effect. If you build something yourself, you really love it. Even if it's like for an outsider, it's like, oh, you know,
It's
not
your
nice.
baby.
Yes, exactly.
Yeah. Oh
Yes.
man, this is
And
carry on. Yeah.
yeah, and then like for example, you build a desk or chair, and this chair is super ugly, right? Because it's not
Don't call
made
my
like
baby ugly.
yes, exactly. But like to you, this is your chair. You build it yourself. Like maybe it took, I don't know, 3 hours, but you made it, right? It's not falling apart. You can sit on this. Yeah, so you really love it. And the same thing happens with software products. People who invest a lot of time into this, maybe it's not super optimal, and then maybe it just goes down like every second hour. But it's still like people invested a lot of time into this, and they have troubles letting go. And I know that I'm myself like that. So having like realizing this is helpful to you know, just to let go things at some point, because there's no point investing more time in this. But at the beginning, like when you spend only 1 week, again, it comes back to these prototyping skills, like just have a simple baseline. And then if it doesn't work, it's easier to let it go, to stop working on this, because you clearly see that your customers are not super excited about this. So it's not something you expected to see. You learn that and you move on.
Yeah. Dang, that's awesome.
Yeah.
Oh yeah, thanks for sharing that. What is a gentle approach to learning more about Kubernetes? I know you're excited about that technology.
Well, yeah, for Kubernetes, I think knowing Kubernetes right now is quite important for employability. At least concepts, not you don't need to know internals, but at least concepts like what are the things are there in Kubernetes is quite helpful to know. And for that, there is a thing called Minikube. So it's basically a small Kubernetes that you can just run on your laptop and then try to deploy a simple service. Like for example, you create a simple service that predicts the price of a car, and then just get a Minikube instance on your machine and try to deploy your web service with this price prediction model in Kubernetes. This will not take more than 5 hours of your time, but this is super valuable to know, and then you won't get lost when you get hired, and then it turns out that the company uses Kubernetes. And then for many people, especially data scientists, this is something scary. Like, hey, I'm not used to these kind of things. This is I'll let backend developers deal with this. This is not my thing. So they just afraid. But Kubernetes made it very easy for people to actually to abstract from these difficult things of auto-scaling, because what I like about this, it makes it super easy to work with infrastructure related things. So it's a very nice abstraction on top of even AWS machines or your own machines that you have. We don't use AWS, but many companies still have their own data centers, and having Kubernetes there is a very good abstraction to for managing all these machines. And it's not that difficult for a user of Kubernetes to learn how to use it. Of course, it's difficult for people who are professionals, like reliability engineer, DevOps engineers. This is their bread basically to maintain Kubernetes cluster. But as a user, it doesn't take too much time to actually learn how to use it. And there are good tutorials in something like Kubeflow getting started. Just follow this tutorial, and that should be enough uh, to be helpful. Also, not wait till somebody with this knowledge implement this, because it's easy to implement yourself. So you shouldn't be scary about Kubernetes. You can actually learn this in reasonable amount of time and already use this knowledge to build useful things.
Cool. And it sounds like Kubeflow is kind of like a really, like it's like the least intimidating way maybe to go about. Cool.
Yeah, Kubeflow is actually like there's Kubernetes and Minikube just to learn about Kubernetes, but there's this thing Kubeflow. Kubeflow is another abstraction on top of Kubernetes for training machine learning models and for serving machine learning models.
Okay. Oh, perfect.
Yes.
Yeah.
Yes. So this is. I'm still exploring it to see how useful it is, but many companies have adopted it and say that this is super useful. They can move a lot faster with Kubeflow. Also, like there are alternatives to Kubeflow, like this is so-called machine learning platforms where you can train a model, then deploy a model. So for example, in case of Amazon, there is AWS SageMaker. It's quite a similar tool for training and hosting models. And I'm sure in Google Cloud or Microsoft Azure, there's something like that as well.
Okay.
And Kubeflow is cloud agnostic, so you can use it in any cloud, and you don't have to use cloud for that. You can just use your own servers, your own data center to also have the benefits of this ML platform.
Okay. Yeah, that's awesome, man. I'm going to dig into that probably, well, tomorrow, because it's getting a little late here, but yeah, I'll be digging into the promises of Kubeflow. So thanks for sharing that. I know we're kind of running. How's your computer doing? We got a few minutes left.
Yes. 10
minutes. Okay. Okay. So these are just kind of wind down questions. So just whatever comes to mind, go ahead, and I think I got like 5 of them. So I'm just going to go for it. Okay.
Okay.
What qualities do you look for in a good meetup?
Well, people that they can talk to, and topics. So free food is helpful, but not a must.
Okay. Yeah.
But mostly like being able to talk to people. So for example, to learn from something else, or not necessarily learn, but maybe find somebody who is interested in my knowledge. And then somebody who wants to listen to what I say is also good.
So people and free food helps.
Well, yes.
Yeah, no, I hear you there. Cool. How do you decide what speaking opportunities to take on?
Well, right now I take pretty much everything because I don't have that many speaking opportunities, and I proactively seek to speak somewhere. And I still learn how to make my call for proposal sound exciting. So actually, I get to speak on conferences because I often don't. So right now, I'll agree to everything.
Yeah. Okay. So you made a promise to yourself, like, I'm going to speak more. And then it's almost like, it's almost like there's a group of people out there that are like, sign me up. And then there's other people. I've just noticed this, like booking people on the podcast. Some people are like, yes, please sign me up. And other people are like, oh, what's the nature of this? And so, yeah, the people, I guess, and their motives. But I was kind of curious what was kind of behind your initiative there. And I look forward to promoting, like, if you want more speaking opportunities, I look forward to help promoting that.
Yes, I definitely look for more speaking opportunities. And if you can, I'll be very happy and appreciate it. Yeah.
This is a real quick question relating to speaking, but I mean, did it just come natural to you, or was there some sort of like transformation you went through that you have some insight on now, like how to be a good speaker, or what's your thoughts on that?
So it's somehow natural, but also in some conferences really go an extra mile, and they want to make sure that the quality of the presentations they have is super good, and then they do some coaching sessions. And I was
Oh
last
wow.
year. I was very happy to get something like this and have an experienced speaker help me.
Okay.
Uh, but yeah, mostly it's not just natural. So I think the main thing is to have a coherent story. So not just a bunch of facts, but try to have a story there. And yeah, and then also one of the things I didn't do, and then I learned from the coaches, is to make sure the audience is never lost. So have every now and then have an outline and somehow summarize what we just learned and what we about to learn, and then at
Mhm.
the end have a summary. So then people leave the room with a clear message in their head, and for that summary is very helpful.
Yeah, that's solid. Dang, thanks for sharing that. That's cool, man. Um, let's see here. 3 favorite learning resources for machine learning. We've got the book. Well, that's
Kaggle.
yeah, Kaggle. Okay.
Well, so the thing I started with is a machine learning course on Coursera from Stanford.
Okay. Excellent.
So even though it's now, I don't know, 8 years old, I think it's still a very good resource to. It's super not demanding in terms of math. It's really just the teacher explains it so well. So then I think it's even after 8 years, it's still a very useful resource to go and watch.
Okay, cool. Any other ones, or those are you're good enough? You've got the
So then there are like more. So for example, from Stanford, there is a very useful course on neural nets for computer vision.
okay.
Um, so there's like CS200. I don't remember the abbreviation. So, but if you Google for neural nets for computer vision, Stanford, then you'll find the course, and it's quite demanding course, but I found it very helpful when I was learning about computer vision.
Okay. So peeling the onion, maybe don't start there, but
Yes,
consider it.
this is
And
like an advanced course, advanced level.
okay, cool. That's awesome. All right. Here's one for you. Best advice you've ever received.
Yeah, so the best advice I received was that was kind of the topic of our conversation, is that math is not as important as you think. As a novice, you think, okay, this is math, I really need to dig deep. It's not that important. What is important is solving business problems and being able to code to solve these problems. And don't be afraid of starting with the baseline. So just you're if instead of machine learning model you have a bunch of if statements, it's equally good. So start with these if statements, start with heuristics, and then if you see that this is helpful, then move on to do something heavier with machine learning.
Cool. Yeah, that's solid, man. Thanks. Okay. The most important book you've ever read, and there's no rules here. It could be like a
Just one,
fiction. Well,
just one book.
well, if you have, I'm going for one, but if you got more, what's your hierarchy of a couple of
Okay, so the first book I ever read and had a big influence on my career was Effective Java.
effective Java? Okay.
Effective Java. Even though it's about Java, as title suggests, it's not just Java. So it does use Java, but many things are quite general. So things like good style, immutability, and things like this. As a software developer, this book had a lot of influence on me. Uh, and especially as a Java developer, so some things were directly applicable to the things I was doing, but also teaching best practices, best coding styles, and then explaining that immutability matters, thread safety, good style, like having good names, all these things. Uh, Then maybe also structure and interpretation of computer programs. Maybe you heard about this one. So this is a pretty old book, and I use this book to learn about functional programming. So it uses Scheme, which is a dialect of Lisp, um, and just reading it and then going through exercises. I think after this book, I understood what functional programming is, like the basics of functional programming, and I could use this everywhere in Java, in Python, and not be afraid of that. And also with time, I realized not to understood how not to overuse this, because people, when they get excited about functional programming, in my opinion, can overdo things. But I think this structure in the interpretation of computer programs is a great introduction to functional programming. Then other thing that I read just 2 years or 3 years ago was designing data-intensive applications. This is a super nice book, and I think it's a must read for any software engineer, anyone who creates code. So it teaches basics of like how to design your systems, how to make them reliable, how to make them available. And then it also goes into basics of data engineering, like what is MapReduce, what is streaming, and things like this. So I think it's I still use this book as a reference. Sometimes I go to this. It's on my desk at home. I often just go through this. And, okay, yes. Now, it's not very demanding, but it gives a great overview of things that were happening in distributed systems. And then it also has references, like if you want to go deeper into some topics, there are references and you can dig deeper.
Okay, cool. Yeah, I've seen that on the O'Reilly. That's one of the O'Reilly books. It's got like a pig or something on the front, like a boar.
I think
or something.
There is
Yeah, that's okay. It's come on my radar before, but I'm very interested just based on your. Okay, thanks for sharing that. What are like the top programming languages to learn in 2020? You can just,
I'm boring. Let's say Java.
Java. Okay.
Assuming you already know Python, of course.
Yeah.
If you don't know, then of course Python for machine learning it's a must. But why Java? So Java is like some people call it Cobol of this century, right? Like Cobol is something that nobody wants to use, but still have to because some institutions still have the software that they need to maintain in Cobol. I don't think Java is Cobol yet. And I think just if you know already Python, then learning a different language like Java helps a lot, just to think differently slightly.
Yeah.
Then I also think, I'm again boring, but JavaScript, I think this is you really need to know it as a software engineer. Even if you want to do machine learning, then sometimes having some kind of like for demonstration, for demo purposes, like if you want to showcase it to somebody, then a web service is the best, like a web page is the best medium for that. And then being able to quickly hack something in JavaScript, I think it's important to convey your message, to convince people. So I'm a bit old-fashioned, so I don't follow the latest trend with languages. And especially now there are so many of them, so I would simply suggest the languages that certainly will have like they are quite old, but they certainly have impact.
Yeah, they've stood the test of time, and
yes, exactly.
And they're still like alive type thing, I guess.
And
so.
Java is still the most popular language in the world according to some indices.
Yeah.
For some indices is JavaScript, and Python is quickly catching up. So I think knowing them is quite good. Also, I think for machine learning engineer, knowing a bit of C++ and C is helpful, because as a Python user, sometimes things just Python is slow. Sometimes you really need to machine learning involves a lot of number crunching, and this is where you don't wait to for a web service to answer. You have CPU intensive workload, and for that, C is the best thing. So sometimes it just helps to quickly write something in C and then use it from Python, and then it can have a dramatic effect on performance, like going from hours to minutes, like from, I don't know, from 60 minutes to maybe half a minute.
Right.
For certain cases, especially when it comes to number crunching, C is still the best language for that.
Dang, I have not had that response yet on the show, and I am forever grateful. That's just more insight into the ecosystem here, and you certainly delivered. So I thank you for coming on the show, sharing all this knowledge. I want to know, what is your call to action here? We've got the book coming out. They can go sign up for the meet. If they want to connect with you, where do they go connect with you?
Twitter,
last words,
LinkedIn, last words. Connect
yeah,
me, follow
call
me.
to action. Yeah, like if you wanted to summarize anything, or this is your time.
Yeah, as a summary, I think maybe the message I was trying to convey is don't go deep immediately. Try to peel the onion slowly. Enjoy the process, and then also move fast. Don't be afraid of breaking things. Then you can learn machine learning just by doing. You don't need to know a lot of theory. And yeah, I guess that's the summary. And also, I'm trying to build my personal brand right now to be more present in online. So I created Twitter like 2 weeks ago or 3. So follow me there. I'll try to post things from time to time. And also LinkedIn. Yes, so I'm more active on LinkedIn. So feel free to connect or follow.
Okay, awesome. And we'll make sure they got the link to the book. The first 3 chapters are out in an appendix right now, and that is continually progressing. And you don't have to wait for the book to come out to jump in and get your hands dirty and start building your portfolio.
Yes, thank you for summarizing it.
Yeah, Alexey, thank you so much for coming on the show. I would love to keep this. Let's do it again sometime. Like, this was seriously rewarding.
It was my pleasure. Thank you for having me. I really enjoyed talking to you.
Yeah, this was fun. Okay, peace out, folks.